Hey folks, welcome out there. Hey, it's Monday and we are here, we're live and we're ready for you to give some calls. 844-686-2378. So number, we hope everybody had a great weekend. Now it's time to get back to school. Oh yeah, all those good things. Hey, good things, get to some math, right? So thank you for tuning in this afternoon. We're going to get to our problem of the day in just a second, but we would just want to thank you for tuning in one more time and also remind you, how do you call in here? You give us a phone call, 844-686-2378. We are here ready to answer work problems and such for you. Actually, I am today. And by the way, I'm Ernie Roberts, and I'm your host for this afternoon's session of Mathline. I almost forgot who I was there. It's a Monday, isn't it? So, but anyway, we thank you all for tuning in, and we hope that you will call in. That's what we would love to hear from you. Make the show rock, 844-686-2378. But to start us off and make it rock first, let's look at our problem of the day. And many of you have already been looking at this on Facebook and such, and we appreciate those things. But here we have it as straightforward to you. Alex has some quarters and $5.15 in nickels. If he has $7.90 total, how many quarters does he have? Blah, blah, blah. Not a hard problem, just a lot of money going on there, isn't it? So let's take a look at this thing and see if we can sort out some of the details here. And word problems sometimes make us all shiver and shake, but this one isn't so bad. So again, we got quarters, nickels, and actually two important numbers there. So let's see what's going to happen if we can go on to our problem here and see how we're going to work through this thing. As we said, Alex has got some good money here. Well, first of all, he has a lot of nickels. Figured that out. That's like 103 nickels. So Alex, wow, quite a bit there. He's got $7.90 total. All right. Now you say, well, Ernie, what is that about? Well, that's how we're going to figure out how many quarters he's got. Now he doesn't have $7.90 in quarters. He's got some nickels and he's got some quarters. All right. So let's take a look at these. I'm going to just play this thing out just to play with it. All right. See what's going on. And let's put it at, first of all, nickels, quarters. And we know that if we put them all together, we have how much? $7.90. Okay? That's the total. Put them all together, everything's good. Now, we have $5.15 in nickels, so we're going to put it right there. Now, what are we going to do with these two numbers to figure out the quarters? First of all, we need to know the value of the quarters. How much are they worth? All right? And that's some good old subtraction time. So off to the side over here, let's do a $7.90, and we'll subtract $5.15. I'd say a lot of you probably went on your calculator to do that, but we'll hit it right here, just good old-fashioned way today. And I'm getting I'm getting $2.75 because we're not borrowing on this, are we? We're going to have let's go through it every way. Everyone wants to see what are we going to do to it here, yeah. So this is going to become an 8, that's going to become a 10. So there's where the 75 comes from, and we still got 2 left over. So we got $2.75. Now, the idea, remember, these two add up to give us $7.90, so life is good there. Now, on the other side of the fence here, so to speak, question is now, how many quarters are those? That becomes pretty easy because we know how much a quarter is worth. 25 cents, right? So we're going to take that $2.75 and we're going to divide 25 into 2.75. Little decimal action today, isn't it? And we're going to need to move that decimal 2 places. This one needs to go also 2 places. And the numbers work pretty easily. We've got 25 going to 27. It's going to go 1 time. Got a 25 coming down here. Another 2. Bring down the 5. And that's going to give us a 1 there. You know what? We have going to put that right there. It's going to be 11 quarters. All right. That's the arithmetic way. All right. It's the arithmetic way to go through this thing. Now, let's look at it from a little algebra standpoint. All right. Because what I want you to think, had I given you the problem and said, Alex has 11 quarters and 3 nickels, and I said, find the total amount. It would be really easy. You just multiply, and add those results. Order of operations. Say you multiply first, then you do the addition, right? What if I had said, I have $7.90 total, and I knew I had, how many coins we had? 103 and 11. So I guess we could say we have, 114 coins that were nickels and dimes. Could we figure that one out? A little bit tougher level. This is kind of one of those intermediate moments, but I want to hit you with the algebra, all right? You said, oh, Ernie, you always love algebra, don't you? Yeah, I do. Yeah, I do. So here's the story. We had $5.15 right there, plus 25 cents times, I'm going to use Q for the number of quarters to give us, in the end, $7.90. So there you go. It's a nice little algebra moment. These are all dollars, by the way. This is cents, 25 cents. That's why there's a decimal there, by the way, folks. That's what we want to have there. So let's see where we're going to go with this. We're going to subtract $5.15. Now, some of you are going like, Ernie, that's what you did right there. Absolutely. It's the same process. All this algebra is a way to put your thinking down on paper, to organize it, to see the process, to see the steps and stuff. So let's see what we've got. Say goodbye to the $5.15 there. It's going to join up over here at $2.75. Here is 25 cents dividing that. We already know what happens when we divide by 25 cents. We did it just a minute ago, right? And so you said, I wish I had that calculator. I did too. And we got Q equaling to 11, and that is your quarters. So, well, again, I just don't want you to be afraid of setting up an equation, an algebra equation, setting it up, because basically it's nickels plus quarters gives me $7.90. And what are we going to do about those? We know what quarters are worth. We've been playing with money all our life, right? So 25 cents times Q, and then we work from there. So there you have it. A start here on Mathline today. And I understand, speaking of which, I've got a caller waiting. Speaking of which, all you other folks who want to call, give us calls, all right? We would love to hear from you today, all right? And, we would love to hear from you. That number again, 844-686-2378. In the meantime, welcome to my first caller for this week. Welcome to Monday Afternoon at Mathline. And who am I talking with?
Chris?
Chris, is that right?
Yes.
And Chris, where are you calling from?
Putnam County.
Putnam County. Cookeville. Are you in Cookeville area or close by?
Yes, Cookeville.
Great. Well, what kind of problem have you got for me today?
Okay, so I have a function table, and I have pairs. I have my x pairs. It's x is 0, y is 0. X is 1, y is -1. X is 2, y is -1/8. X is 3, y is -1/27. And x is 0, y is -1/64. And I have to write those in an equation. And I know they're cubes. I'm just not sure if it's a square root.
Okay.
Those in my equation.
Right. Okay. Can you read those out to me? I'm trying to get my numbers here straight with you. You've got an x and a y. You basically have a table, right? That's what's going on.
Right.
Okay. Let's go back and just take the numbers just kind of slowly with me. Your first x and first y, what have you got matching up here?
0, 0.
All right. So that helps us a little bit. What's your next one?
1 and -1.
1 and -1. Okay. And your next one?
2 and -1/8.
Wow. Okay. And our next one?
3 and -1/27.
-1/27. All right.
4 and -1/64.
All right. Let's see. So what we're trying to do is figure out what's going on. And you're feeling like there is, it looks to me, I thought I saw a pattern for a little bit here. And this is the 2 and is it -1/8 or -1/4 on the 2?
It's -1/8. So those are all cubed.
Okay. All right. So, and it looks like it looks like what your value here is, and it's what you're saying. Let's look at something here. And all right, we're sort of thinking about it being x cubed, right? The one thing is, so
yes.
It's making it into what? It's making it into a fraction. So I'm looking at it, it feels like I'm seeing first of all, 1 over x cubed. You see where I'm going with that?
Okay.
Because, and the 0, that's the only thing. It's not going to work with the 0 function, though. That's where it's kind of a little bit strange. So, because if you take 1 over 0, it's going to blow up. You're not going to get a 0 there. So that's bothering me. Okay, you see what I'm saying on that?
Mm-hmm.
I'm also looking at thinking if we were to say, basically it's like saying now it looks like we're changing the signs from positive values to negative values here, doesn't it? So I'm thinking we got a y equals a negative 1 over x to the third, which would give us all those values except for the 0 one. Was that definitely in your table already? Or is
No, I have to write the equation.
All right, let's get rid of 0, 0, because it's not there, okay? That's what I was asking. The 2 zeros are not part of the...
Oh, yes, the 0, 0 is there.
They are there. Well, that is not going to fly, because here's what happens. Let me show you. When we take 1 divided by 0, we get an error, because we cannot do that. Now, everything else was looking pretty happy there and such, but as I said, that's for these your rule holds, but I don't think we can. We may have for this I'm going to say f of x equals. I'm going to go one step further here. F of x is equal to, and that's what y is. You know that, right? I'm going to say negative 1 times 1 over x to the third, but I'm going to state we have to have where x either cannot equal 0 or we want to. It looks like in this case we need to keep it x greater than 0. Okay, keep it positive. Looks like it'll work better there, because when we put in with the numbers you've got there, it's just simply we're going to say 1 over that. We're going to cube it, put 1 over that, and change the sign, which is going from positive to negative. But that 0, I don't know how we can fix that. That's the catch there.
Right.
But your rule holds through everyone else there that we've got here. This right here, or using this approach right there. Does that help a little bit?
It does. So do I not need to put a square root somewhere in my equation?
I don't see that you're dealing with a square root here, because you're going from x to y, correct?
Correct.
Now, if you were wanting to come backwards, if you were going to say what's the relationship between, let's say you're going to say x equals y, you'll be looking at a cube root of y. You'd be using an inverse function there. And even then, you're going to be using it would be the opposite of that cube root. It would be a negative cube root of y. So in other words, if you had this, put a little negative out there, that's your relationship between if you're going backwards. So in other words, if I put a negative 1 in here, the cube root of negative 1 is, and it may be 1 over cube root. I believe we'd be probably looking, let's see. That's not really what you're trying to do, is it? Work backwards to x equals? Because that would be the only place.
I just need to write an equation that makes my function table true.
Well, this is the closest you get, and you just have I would just put a stipulation that x is had to be greater than 0. Or x cannot equal 0, because that one blows, it messes it up, period, if you've got, especially with the fractions that you're coming up with. Do you follow what I'm saying?
It look like that to you? Okay, thank you so much.
Does that help some? Because this I think was just, I thought you were, and that really doesn't help the situation either. I was trying to see if that might do something, but I may have to think on that one with the 0, 0 part. Maybe we've got, but as long as we're making 1 over, that's kind of crossing me up a little bit. Okay? You got it?
All
okay.
Right. Got it.
Hey, thank you.
So much.
And I'll look at that and may ask some colleagues here to see what we've got going on, okay? So thank you. Sometimes we have problems that get interesting, and you sit with one thing, and there may be another way to get out of that thing. I'm going to check it out and see if we got some folks who can help us out on that along the way. If anybody's got some ideas, hey, give us a call about that thing, how that 0 is supposed to work in there, or maybe we've got another option to go with there. I tell you. All right. And anyway, back to all the good stuff here. We want to give some calls, all right? And we had a great one. Chris, thank you for calling. I got us stimulated here on Monday. Really kind of had to think a little bit. So problem is working there pretty much, except for one little problem there, one little catch there. So another way we could look at that possibly is looking at it probably from the standpoint of we could look at it from the standpoint of a graph on the graphing calculator. So let's go there. We got some time. We don't have any calls waiting for me, guys? All right, let's do something kind of crazy here. All right, since we're waiting for calls, we'll do that. But let's say what we're going to do is we're going to clear out our list. Some of you are going, whoa, Ernie, where did you just go on that? I'll tell you here in just a second. Let me go back here and clear. But what we're going to do is we're going to use the stat. We're going to graph some here, okay? We're going to graph these points and see what kind of situation we're looking at. Whether she's given me a lot of ordered pairs, and we're going to see if it actually fits a curve of some sort. I still think that 0, 0 is an unhappy camper there, but we may find something it'll work with. So taking a look and seeing where we're going to go. By the way, we got there. Some of you are going, what did you just do? I'm going into what we call stat mode, all right? And there's a stat key right about there that I just put a red on, okay? And it says edit. And what that's going to do, we press enter for edit, and that's going to give me some list. And what I'm going to do, I'm going to let the X and the Y be list 1 and list 2. So Chris gave us some numbers here. We had X equals 0. I'm just going to put them all in there she gave me. Let's see. Find them. What happens when you move them? There they are. 1, 2, 3 is just simply 1, 2, 3, 4. That was easy. All right, then we're going to put in a 0 over here. We're going to go over to the list 2, and what we're going to do is put in the Y values that correspond. We can't mess them up, all right? So we're going to put a 0 in there, and we'll come down with a -1. And let's see, enter. We'll put in a -1 over 8. Enter. And we'll get a -1 over 27, which is going to be kind of crazy looking. Everybody hopefully see what we're doing there. We're basically matching up some things, and unfortunately that's not going to be a perfect, it didn't come out even, so they've rounded here a little bit, but we'll go with the best we can there. And then we've got our last one is a -1 divided by 64. Be sure you're putting negatives. Don't put the minus sign on those. It helps me to leave a 1, put in a 1 there, okay? Clear that. Let's go back in. Oh, come on, get me back there. Some of you are going, did you lose everything? Nope. There it is. Sometimes that happens. That makes you kind of freak out a little bit. Let's see. Put that negative. Got to have a 1 divided by 64. So the calculator is forgiving. It stores everything you've already put in there, so you don't have to go back to square one. So there again, it's rounded that off a little bit. Let's see. Let's go to what we call a stat plot. And we're going to turn one on here. And we're going to hit on. And what we're going to do, we're going to make a scatter plot. And those of you who use these in your high school and middle school thing, we're going to use right there, we want to hit the scatter plot. And we're going to see what happens there. We've got list 1, list 2. Color's going to be red. And what I'm going to do to help us out a little bit here, because I'm wanting to see kind of how this is behaving, is we're going to do a zoom. We're going to do a zoom. I'll get it right in a minute here. We're going to do a zoom 9, which means zoom stat. Okay, so hit the zoom, and let's go down to number 9. Let's see what we got. We got points that look like so, and then we got this strange one up here. That's our 0, 0. That's why I don't think 0, 0 is supposed to belong to this puppy, okay? Because what we're seeing here is there's a nice little curve being fit here. And what we could do there is, let's see, we do a little regression on that and see what happens. I don't think it's going to like the 0, 0 part, but let's see. It'll get close. It'll do something with it. All right, so let's do it back to stat. Nope. How about it? The stat and calc. And then we're going to do what we call not a linear, but we're going for a cubic because we think it's somehow relating to the being cubed. And could be, it looks like it's more like a cube root type situation. We'll see what's happening here. Let's see what's happening. It actually should be a cubic. As I talk to myself, y'all got me out there? All right. So let's see what happens here. Let's enter. Let's calculate and see what it gives us. It gives us something kind of crazy, all right? Which is probably not what we were looking for there, but it's because it's doing some round off, and that 0, 0 is really messing things up, all right? So my feeling is a correlation isn't that great. I think if we took out 0, 0, once again, we'd have something that really looks pretty sweet, pretty close there, and where we would have a -1. But again, remember, we decided it was going to be 1 over x cubed. So that really kind of messes things up a little bit there. So that's not really what we're after. But let's try this. Let's try what we thought it was going to be. Let's pick up -1 divided by x to the third. That was what we decided our function was going to be. We thought it would be. Let's see what happens when we graph. We got those points already. Look at that. It hits all 3 of those. Graph hits that. So we are in good shape with that. The 0, 0 is not a happy point. So again, Chris, I think that 0, 0 somehow is not working for you there, all right? But everything else we did, those 4 points there worked beautifully into the formula. So again, some of you have anything idea better on it? Let me know how to get that 0, 0. I think it's a mistake there. All right, so enough of that. All right, let's go back to a problem we left off on Thursday last week. Cliffhanger, so to speak. We had great calls. We had some great calls coming in. So we had left you at basically this point. I had someone even sending on Facebook says, I like where it is. It's going to work out. It's going to be great. And it really will be. All right, let's go back and look at this problem for some of you joining us today that weren't here on Thursday. We decided, based on triangles, and that's what all triangles do, if we got an angle out here that's working supplementary here, we call it an exterior angle of that triangle, it works together with these 2 little guys here that are remote interior. In other words, they're far away and they're on the inside of the triangle from this exterior angle. Words, oh, they just sound like where they are. All right, yeah. So what we've got here, we took this quantity, which is 46x plus 6, bang, there it is. And 18x plus 4, woohoo, right there it is. And then we got 70x minus 2 on this side. We have it going there, all right? Now, what do we do from here? What do we do from here? We need to get like terms again. That's what we did. It's where we were last week. We had 64x plus 10. Life was good. Over here we had 72x minus 2 still hanging out. Now it's time to do some manipulating. We decided let's subtract the 70x from both sides. It's going to leave me with a -6 plus the 10, which equals -2. Now at this point, folks, we need to subtract 10. And I was running out of room, so I didn't show that subtract 10 moment there, but I can do that over here. Let's see, if we have 6x plus 10 equaling to -2, we'll subtract that 10. And we're going to have 6x, looks like, equaling to -12. But we've got a negative on that 6, so we got to keep that. Can't lose that. Sometimes we like to throw things away, but there we go. -6x plus 10 equals -2. Now we're getting to business. We're going to get an x equals nice number equaling to 2. And I think that's really good because if you will go back, let's plug it in because we're looking for angle measures here. We got x. That's delightful. That's wonderful. But now it's time to go find these angles. And we want to make sure these 2 guys are going to do what? They're going to add up to give us the big guy out here. All right. So let's put it in here. Put a 2 in there. I'm getting, oh, nice, nice. Oh, very nice. 18 times 2, double that 18, you get 36. Add 4 to it. I'm going to get us 40 right there. All right, there's 40 degrees. Out here, let's go ahead and put this thing in there. 70 times 2, woo, 140. We're going to subtract. We'll get 138 degrees. And back up here, we're going to put that 2 in. Ah, my goodness, double 46, get a 92. Whew. 92 plus 6 gives us 98. And my friends, do they check out? That's the big question. I've got 40, I've got 98. Does it add up to 138? Absolutely it does. You can do that mental check business, all right? But there you have it. Wow, we picked that up. And for those who were just joining in on it today, I hope you kind of see what we did. Exterior angle theorem says add these 2 together to equal that. then play some algebra, get like terms together, move things around, and end up with a nice answer of 2 for x, and then find your angle measure. Substitution finishes it off. Hey, thank you for tuning in today. Thanks for a great call to get us started here, and some really having to think about some number sense there and all. So again, we're here live most of the days, but tomorrow probably not going to be back here live. We're going to be back Wednesday and Thursday is our plan right now. So keep your problems, keep your numbers, keep all those things ready. But we're still going to be around on Facebook. We'll probably have that problem of the day for you just a little bit. And you can go ahead and play with that, but we'll deal with it on Wednesday. We thank you for tuning in today. It's exciting to get back from the weekend and excited to have a little bit of math going on here. And again, we'll be looking forward to seeing you again next time.